All right, our next factoring type is called factoring with difference of two squares or difference of perfect squares. It's probably the fastest factoring technique you'll work with. And so this probably will be the quickest video because there's not a lot we got to go happen here. What you'll notice with difference of squares factoring is you only start with two terms, and that is always the case. It will be two terms. They will always have a minus sign between the terms. That's where the word difference comes from. The word difference means subtraction. And everything that you are working with is going to be a perfect square. So perfect squares are things like 9 or 25 or 36. Or your variables could be perfect squares like x squared and y squared. The way that we factor difference of squares is we essentially are just taking the square root of each one, and you're going to get one of your factors to be addition, to be positive, and one of your factors to be subtraction or negative. So to jump into the steps and the examples, when you're doing this, the first thing you want to check is see, does it have a GCF? Before you get really involved with difference of squares, sometimes there's an extra common factor you can take out. And then once we have that done, or check to make sure that there's nothing we can do there, you want to see if your A and B value can be written as a perfect square. If so, we're going to use that to factor it for us. So here we go. You'll notice, again, two terms. You'll notice a subtraction between those two terms. Everything here is a perfect square, the numbers and the variables. So when you factor it, you're going to take the square root of 25, that is 5, so you're going to put a 5 here and a 5 here. Square root the x squared, so you're going to get an x here and an x here. One will be positive, one will be negative. Square root of 49 is 7, so you're going to have a 7 here and a 7 here. And again, there is no difference if you put the addition one first or second, as long as one is positive and one is negative. If you're working with numbers that you don't know the square root, you can definitely grab a calculator. Next one, again, we have a subtraction. 16x squared, you'll get a 4x and a 4x. One will be plus, one will be minus. And then 81, you'll get 9 and 9. You'll notice on the next one, you might notice right away, okay, it's subtraction, that's great. It's a y squared, that's great. 8 and 18 are not perfect squares. So if they are not perfect squares, you want to see if there's a GCF you can take out first. So for example, in 8 and 18, they're both divisible by 2. So we're going to take out a 2. Now we are left with a difference of squares. We have a subtraction and we now have perfect squares. The 2 that I brought out is still going to stay there. We're going to break up our factors. One of them is going to start with a 2y and have a plus. One of them is going to be a 2y and a minus, and that comes from square rooting the 4y squared. And then the 9 is going to be a 3 and a 3. And the nice thing with these, if you want to check and see if you're right, you can always FOIL them back together, multiply them back together, and you will get right where you started. Next one, you have a 9x squared, which will break down into a 3x and a 3x. And then a 16, so you're going to have a plus 16 or plus 4 and a minus 4. I do want to mention something on Delta Math because it's where students have had trouble before. If it's written in this order, so let's say it's written as 25 minus 16x squared, and students will ask, does it matter the order? It really does. You need to follow their order. So if they write it like this, where they have the constant coming first, you need to make sure that when you put it in parentheses, you put that constant first. So you start with the 25, so square root of that, you get 5 and 5. Again, one will still be plus, one will still be minus. And then 16x squared breaks down into a 4x and a 4x. So I wanted to mention that because I've had students in the past wonder why they were missing things. They were trying to kind of flip this around. You want to keep it in the order that it's written, and you want to make sure you write your factors in that exact same order, or else it will tell you that you're wrong. Last couple, just real quick, 64 is a perfect square, so is 121. So this breaks down into 8x and 8x. One is plus, one is minus. The square root of 121 is 11. If you don't know that, you can definitely use a calculator to find it. So you get 8x plus 11, 8x minus 11. And then for this one, the square root of 100 is 10, and then you'll have an x. And if you have 1, the square root of 1 is just itself. It is 1, so you get plus 1 minus 1. One other comment before you go to Delta Math to make sure you're comfortable, you will have ones that could have higher powers. For example, you could have something that is an x to the 6th. When you break that down, x to the 6th breaks down as x to the 3rd, x to the 3rd. So you're just cutting that power in half to break it down, and then plus 2 and then -2. So it is possible to have higher powers. When you are splitting it up and factoring, you'll just basically cut that power in half and put that in each spot. And that is how you factor difference of squares.